Factors and multiples. Spiral learning. Knowing about factors and multiples. Factors by division. Factor tree. HCF and LCM. Factors. What are factors? Let us find out factors using multiplication. Pinky has punched out 12 paper flowers. She wants to place them on a card in equal groups. Let us help her. 1 into 12 or 12 into 1, 2 into 6 or 6 into 2, 3 into 4, 4 into 3. We observe that equal grouping cannot be done using 5, 7, 8, 9, 10 or 11 paper flowers to get a total of 12. We observe that only some numbers give 12 with equal grouping. 1 into 12 is equal to 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. These numbers in increasing order are 1, 2, 3, 4, 6, and 12. The numbers which can equally group multiply to give a required product are called factors of the product. So, we can say that 1, 2, 3, 4, 6, and 12 are the factors of 12. Now, let us find the factors of 28 by multiplication. 1 into 28 is equal to 28. 2 into 14 is equal to 28. 3 into is equal to 28, not possible. 4 into 7 is equal to 28. 5 into is equal to 28, not possible. 6 into is equal to 28, not possible. 7 into 4 is equal to 28, repeated factors. Stop trial multiplication after a pair of factors repeats. Selected multiplications are 1 into 28, 2 into 14, 4 into 7. So, the factors of 28 are 1, 2, 4, 7, 14, and 28. Looking at the factors of 12, 28, and other above given numbers, we observe that 1 is a factor of all numbers. 1 is the smallest, lowest factor of all numbers. 1 is the common lowest factor of all numbers. The number itself is its own factor. The greatest factor of a number is the number itself. All factors of a number are equal to or less than the number. Each number has countable number of factors. Finding factors by division. We had earlier found the factors of 12 by multiplication. Now let us try to find them using division. These are 12 tennis balls. Let us place them in boxes through different ways. 1 box. 1 group of 12. 12 divided by 1 is equal to 12. 2 boxes. 2 groups of 6. 12 divided by 2 is equal to 6. 3 boxes. 3 group of 4. 12 divided by 3 is equal to 4. 4 box. 4 group of 3. 12 divided by 4 is equal to 3. Equal grouping in 5 boxes to give 12 is not possible without remainder. 6 boxes. 6 group of 2. 12 divided by 6 is equal to 2. 12 boxes. 12 group of 1. 12 divided by 12 is equal to 1. Equal grouping in 7, 8, 9, 10, 11 boxes to give 12 is not possible without remainder. Let us summarize. Division fact. Multiplication fact. Factors. 12 divided by 1 is equal to 12. 1 into 12 is equal to 12. 1, 12. 12 divided by 2 is equal to 6. 2 into 6 is equal to 12. 2, 6. 12 divided by 3 is equal to 4. 3 into 4 is equal to 12. 3, 4. 12 divided by 4 is equal to 3. 4 into 3 is equal to 12. 4, 3 repeated. 12 divided by 6 is equal to 2. 6 into 2 is equal to 12. 6, 2 repeated. 12 divided by 12 is equal to 1. 12 into 1 is equal to 12. 12, 1 repeated. So, the factors of 12 are 1, 2, 3, 4, 6, and 12. The numbers which can divide the given number without leaving a remainder are called its factors. Now let us find some more factors by division. Example 1. Is 5 a factor of 48? Solution. Here is the sum. 5 is not a factor of 48. As on division it leaves 3 as a remainder. Example 2. Is 7 a factor of 119? Solution. Here is the sum. 7 is a factor of 119. As on division, it leaves no remainder. Example 3. Write all the factors of 29. Solution. 29 is divisible only by 1 and itself. So, the factors of 29 are 1 and 29. Factor trees. A factor tree is a representation of a number along with its selected factors. It also shows us how different factors multiply and make a number. This means the same number can have different factor trees. Example 1. Draw different factor trees of 18. Solution. To build a factor tree, we write the number on top and write the factors downwards. Factors which can be divided further are circled and divided into further factors. We stop the division when all factors left are prime numbers. A. 18. 1 into 18. B. 18. 2 into 9. 2 into 3 into 3. C. 18. 3 into 6. 3 into 2 into 3. Example 2. Draw any three factor trees of 24. Solution. A. 24. 2 into 12. 2 into 2 into 6. 2 into 2 into 2 into 3. B. 24. 4 into 6. 2 into 2 into 2 into 3. C. 24. 3 into 8. 3 into 2 into 4. 3 into 2 into 2 into 2. Observe that the bottom line of factors in each factor tree is the same. Common factors and highest common factor, HCF. Factors which are shared by two or more numbers are called common factors. The greatest common factor is called the highest common factor, HCF, of these numbers. Example 1. Find the common factors of 8 and 20 and their HCF. Solution. Factors of 8 1 into 8 is equal to 8. 2 into 4 is equal to 8. And factors of 20. 20 divided by 1 is equal to 20. 20 divided by 2 is equal to 10. 20 divided by 4 is equal to 5. Common factors of 8 and 20 may be shown as: common factors of 8 and 20 are 2 and 4. Between 2 and 4, 4 is greater. Hence, the HCF of 8 and 20 is 4. Example 2. Find the HCF of 16, 12, and 24. Solution. Factors of 16. 1 into 16 is equal to 16. 2 into 8 is equal to 16. 4 into 4 is equal to 16. Factors of 12. 1 into 12 is equal to 12. 2 into 6 is equal to 12. 3 into 4 is equal to 12. Factors of 24. 1 into 24 is equal to 24. 2 into 12 is equal to 24. 3 into 8 is equal to 24. 4 into 6 is equal to 24. Common factors. Common factors are 1, 2, 4. So, the highest common factor, HCF, of 16, 12, and 24 is equal to 4. Prime and composite numbers. We know that all the numbers have 1 as their smallest factor and the number itself is its greatest factor. The numbers may or may not have any other factors. Observe the following circled numbers from 1 to 20. What can you say about their factors? We observe that these numbers 2, 3, 5, so on, 19, have only two factors, 1 and the number itself. Such numbers are called prime numbers. Other numbers have other factors too, apart from 1 and the number itself. Such numbers are called composite numbers. There are many more prime numbers and composite numbers beyond 20. We can pick and choose them by checking whether the number of their factors is 2 or more. Example 1. Is 64 a prime number? Solution. Factors of 64. 1 into 64 is equal to 64. 2 into 32 is equal to 64. 4 into 16 is equal to 64. 8 into 8 is equal to 64. Factors of 64 are 1, 2, 4, 8, 16, 32, and 64. Since 64 has more than 2 factors, it is not a prime number. Example 2. Is 1 a prime number or a composite number? Solution. Factors of 1. 1 into 1 is equal to 1. 1 has only one factor, that is, itself. Hence it can be neither prime nor composite. Multiples. What are multiples? To understand this, let us revise the multiplication table. Skip count by 2, color every second number. The numbers we get are 2, 4, 6, 8, and so on. This gives us the multiplication table of 2 till 10 times 2. These numbers are also called multiples of 2. When a number is multiplied by 1, 2, 3, 4, and so on, the products formed are called its multiples. Looking at the multiples above, we observe that a number is the first multiple of itself. Every number is a multiple of 1. Every multiple of a number is equal to or greater than itself. Each number has uncountable infinite number of multiples. Checking for multiples. Example 1. Is 54 a multiple of 8? Solution. Let us divide 54 by 8 and check for remainder. 6, 8. Here is the sum. 8 does not divide 54 completely. It gives 6 as remainder. Hence, 54 is not a multiple of 8. Example 2. Is 78 a multiple of 6? Solution. Let us divide 78 by 6 and check the remainder. Here is the sum. 6 divides 78 completely without leaving a remainder. Hence, 78 is a multiple of 6. Example 3. A. Write the first 5 multiples of 20. B. Write any 5 multiples of 11. Solution. A. 1 into 20 is equal to 20. 2 into 20 is equal to 40. 3 into 20 is equal to 60. 4 into 20 is equal to 80. 5 into 20 is equal to 100. The first 5 multiples of 20 are 20, 40, 60, 80, and 100. B. 3 into 11 is equal to 33. 5 into 11 is equal to 55. 8 into 11 is equal to 88. 10 into 11 is equal to 110. 20 into 11 is equal to 220. Any 5 multiples of 11 are 33, 55, 88, 110, and 220. Common multiples and least common multiple (LCM). Multiples which are shared by 2 or more numbers are called common multiples. The lowest common multiple is called the least common multiple (LCM) of these numbers. Example 1. Find the 3 common multiples of 5 and 10 and find their LCM. Solution. First 6 multiples of 5 is equal to 5, 10, 15, 20, 25, 30. First 6 multiples of 10 is equal to 10, 20, 30, 40, 50, 60, 10, 30, 15, 20, 25, 40, 30, 50, 60, 20, 60, 10, 10, 50. Common multiples of the 5th and 10th may be shown as 5, 5, 15, 20, 25. Common multiples of 5 and 10 are 10, 20, and 30. Among them, 10 is the smallest. Hence, LCM of 5 and 10 is equal to 10. Example 2. Find the LCM of 12 and 15. Solution. Multiples of 12 are 12, 24, 36, 48, 60, 72, and so on. Multiples of 15 are 15, 30, 45, 60, 75, 90, and so on. Hence, the LCM of 12 and 15 is 60. Lab activity. Objective: to recognize multiples and common multiples of given pair of numbers. Materials required: squared paper 10 times 10 with numbers 1 to 100 printed on it, crayons of 3 different colors. Procedure: 1. Group students in pairs. Give each pair a squared paper sheet and 3 crayons. 2. Ask one group to color any two numbers between 2 and 9 on their sheet with 2 different colors. Ask the group to color the multiples of these 2 numbers with the same color and common multiples with the third color. 3. Repeat with each group by giving different pairs of numbers. For the numbers 5 and 6,